My goal is to get a complete view of all our address data, standardize it, and understand and improve its quality so we can confidently build spatial analytics and AI capabilities on a foundation of trusted data. I'll start with Gio AI Assistant to better understand what address data I have available. While I could navigate to Suite's catalog to start to explore my data, conversational search makes a great entry point for business and technical users alike. I'll start a conversation with Geo about what kind of data I'm looking for and why. Geo has surfaced some address data sets that should be useful for us. I can follow up with another question to gain more context about what data sources are connected and what kind of data they contain. Great. So Geo confirms that we do have valuable address data living in our legacy system. This is a common situation. That data is already supporting critical operational workloads. But where it lives today, it's difficult to continuously govern, enrich, observe, and improve alongside the rest of our data. I don't want to replatform the system or disrupt production. I just need a safe, reliable way to work with this data downstream so I can observe and improve its quality and trust it for analytics and AI. That's where continuous replication comes in. It gives me an always up-to-date copy of the data to work with, without changing how the source system runs. So instead of switching tools or managing configs, I'll just ask Geo to help me set up a replication pipeline. If you've begun a replication effort, you can select that here. Otherwise, you can start a new replication project. And Geo presents me interactive menus to gather the key information it needs from me, such as the source and the target database. I can simply ask Geo to tell me about the available schemas so I know what I want to bring in. And here, I can filter out the noise and only bring in the schemas and tables that I'm interested in. Now all I have to do is confirm the table mappings. The replication pipeline is now configured and ready to start securely and continuously replicating data into our target system. So far, we've used conversational search to understand what data we have available, and set up replication for one of our legacy systems to break down data silos and enable data integrity efforts without disrupting key operational workloads. Now that we've connected and profiled the data, the next step is making it usable, not just technically, but from a business perspective. To do that, we'll start with Geo. Instead of browsing through tables or schemas, I can just start a conversation. I think I want to use the serviceable addresses data in Snowflake for some analysis. How trusted is it? So Geo immediately finds the dataset we just connected to and brings it into focus. And what's important here is that Geo isn't just pointing me to a table, it's surfacing context, quality indicators, and what we know about this data so far. Right away, I can see a high-level quality summary. Completeness, validity scores. This gives both technical and non-technical users a fast way to understand whether this dataset is ready to be used or needs attention. Let's get some more context on how this data fits into our business. What policies are relevant to using this data set? And do these represent customer addresses? And Geo surfaces the governance information that's linked to this data set. This is all possible because the Data Integrity Suite's catalog holds governance and quality as first-class citizens alongside your metadata.
We've asked what we need of Geo, we can just as easily hop over to the catalog to explore on our own.
Geo has linked us to the relationship details within this dataset. Let's view the overall dataset details. At this point, not everything is filled in, and that's intentional. Cataloging isn't just about capturing metadata, it's about building understanding over time. We can use AI assistants to generate descriptions for our datasets, and even our fields, saving us time and instead leveraging our human expertise to validate and certify descriptions. To quickly build up a base of contextual understanding around our data, what it represents, how it should be used, and why it matters. That description isn't just helpful for people. It's equally valuable for AI systems that need to understand what this data represents and how it's intended to be used. Here we can see that our dataset may be linked to relevant business terms. For example, service address, helping connect the technical metadata to real business concepts. These business terms can also roll up to domains, giving us broader organizational context. This highlights an important differentiator. The catalog is built on an open, flexible metamodel. We're not limited to static metadata. We can extend this asset with business-oriented indicators, relationships, certifications, and meaning that helps users quickly understand the data and trust it. Now let's look at data quality more closely. Because quality is closely integrated with the catalog, I can see and manage quality rules right alongside the metadata. I can review existing evaluations and see where the data meets expectations and where it doesn't. If I want to add a new rule, I can do it using AI assistants. We can write a data quality rule once and then set it to target any number of compatible fields or datasets. And as always, it runs where your data lives. For example, I might say, customer IDs should only have numeric characters. And the suite transforms that intent into a rule we can apply. In the main rule builder, we can apply AI-generated sample records to test our data. The suite shows me AI-generated sample records for testing and lets me validate my logic before confirming. AI Assistants has also populated a description of the rule I've written in plain language. And once I save it, this rule doesn't just belong to this one dataset. This is a build once, apply everywhere model. Because this rule is defined at the field or concept level, it can be reused across other datasets, even ones that don't exist yet. That means we're not just fixing today's data, we're establishing guardrails for the future. At this point, we've brought quality and governance together. We know what the data means, we know which fields matter most, how trustworthy the data is, and we've defined reusable rules that scale across the organization. This is what trusted, business-ready, and AI-ready data looks like. But identifying issues is only part of the story. The next step is acting on them. Cleansing, standardizing, validating, and enriching the data so it's ready for real use. For that, we'll move into pipelines. Understand the structure and quality of this dataset, and we've defined the rules and business meaning around it. The next step is to improve the data itself. So I'll set up a reusable pipeline that can remediate quality issues with our address data today and in the future. Right away, you can see each step this pipeline will run through: standardizing and verifying the address, geocoding it, enriching it with location intelligence, and we can even apply some custom transformations. Let's walk through the operations that happen behind the scenes when we run this pipeline, and set up a couple new steps as we go along. On the left, we see a node representing our input dataset. From here, we can add steps at any point as data flows down the pipeline. Let's add our first step. Having clean and consistently formatted string data is more important than ever, now that AI systems will be consuming this data in addition to humans. When it comes to parsing and cleansing data, in addition to many string operations available as out-of-the-box pipeline steps, we also have pre-built and validated pipeline operators for parsing phone numbers and email, for example. We also have a step that helps us standardize date fields. When we add a step to our pipeline, we can easily preview the transformation on a sample of data so pipeline development is seamless.
Now for the main event. Let's improve our address data. In the verify address step, we confirm whether each address is real, complete, and correctly structured. Records that were previously inconsistent or ambiguous now become standardized, reliable entries. Since we're working with US addresses in this example, we see addresses, where possible, are enhanced with the correct zip+4, which improves delivery accuracy, location matching, and downstream segmentation. Next, we use Precisely's best-in-class geocoding capabilities. Every record is now assigned accurate latitude and longitude based on authoritative reference data. This unlocks everything, from spatial analytics to network planning to proximity-based AI models. We can see in our step preview the result of the geocoding. Now that we have the Precisely ID, based on precise geocoding for each address, we unlock powerful ways to take advantage of Precisely's enrichment datasets. We can select from hundreds of attributes that give business meaning to each address, such as building type, characteristics of the property, commercial versus residential indicators, and other spatial insights that help guide real decisions. This pipeline can apply custom logic, such as removing special characters and normalizing field formats, since AI readiness requires more than just good address data. I could specify a custom coding step or LLM transform in the same way I added a step before, but I'm feeling chatty. Let's start a conversation with Gio AI Assistant. I'll start a conversation. Help me standardize customer ID values by padding them to 8 digits with leading zeros. And Gio creates the step for us. Of course, we can preview the transformation just like any step we've created manually. And this isn't a black box. We can open up the editor for this step to view the underlying JavaScript code and use AI assistants to change the behavior as we desire. I'm also going to give this step a more descriptive name. So that's our quality pipeline. What started as an inconsistent, unreliable address table is now a trusted, validated, geocoded, and enriched dataset, complete with unique identifiers and all the contextual details needed for accurate analytics and AI models. And because all of this is configured inside the suite, the transformation is fully governed, repeatable, and easy to monitor going forward. Our quality pipeline can even be exposed as a real-time service, unlocking powerful possibilities and keeping you in control of your data quality. To recap, we've quickly connected to data, profiled it, and gained an immediate view of its high-level quality. From there, we were able to dig deeper, evaluating issues, cleansing the data, and enriching it to ensure it's truly fit for purpose and AI ready. But high-quality data doesn't stay high quality on its own. Now that the data has been fixed and enhanced, the next question becomes, how do we make sure it stays trustworthy over time? That's where observability comes in. Let's take this newly improved dataset and set up proactive monitoring so we can detect freshness issues, anomalies, and drift before they impact the business or an AI model. So the next step is to make sure this trusted, enriched dataset remains reliable as new records come in over time. I'll create a new observer for this dataset. Right away, I can choose the types of issues I want the suite to watch for. With observability, we're watching for things like sudden drops in volume, delays in freshness, shifts in value distributions, or subtle format changes, all of which can quietly degrade trust and impact analytics or AI models if they go unnoticed. For example, if this dataset normally receives 20,000 new address records each week, and suddenly only 2,000 show up, observability will automatically detect the drop and alert us. If new data stops arriving when it normally would, observability can flag that before outdated data gets used in reports or models. Or if the distribution of values starts shifting, for example, zip codes or building types suddenly appearing much more or less frequently, that can change the behavior of an analytic or AI model trained on this data. I'll enable these monitors and save the observer. To see how this works in practice, here's an existing observer with alerts already triggered. You can see a clear explanation of what changed, when it happened, and how significant the deviation was compared to typical patterns. This gives teams the ability to catch issues early, long before they impact reporting, AI training pipelines, or operational workflows. And observability learns from your metadata over time, proactively asking the right questions so you get alerted before any impact to your AI models or BI analytics initiative. With observability in place, we now have continuous assurance that the trusted, enriched data powering our decisions and our AI stays trustworthy as it evolves. Now it's time to operationalize our data. Now that our address data is trustworthy and continuously monitored, the next step is to put it into motion, making it available to the people and systems that need it. And this is where workflow comes in. Workflows in Data Integrity Suite are powerful and flexible. If you'd like, you can trigger email notifications, forms, and more when changes are detected on a data quality score, for example. I'll start a new workflow, and instead of triggering it from a data event, I'll use something many teams rely on day to day, a request from a user. I'll show you how simple this is for that user. Right from the catalog, they might request access to a governed dataset like the enriched address table we just created. Here they can add details or justification, and the workflow takes it from there. Let's take a look at what's happening behind the scenes. You can define custom workflows for your business using the intuitive drag and drop editor. We might have an automated step that forwards this request to Jira. All I have to do is paste in the endpoint, the authentication details, and the fields we want to populate. The workflow handles the rest. No copy pasting between systems, no manual ticket creation, no delays. When a user requests access right from the suite, the workflow runs and it automatically creates a structured Jira ticket with all the right metadata. The dataset requested, who asked for it, why they need it, and the context pulled directly from the suite. This creates a loop that usually involves emails, spreadsheets, and a lot of back and forth. And because this dataset is governed, the request is always tied to the right definitions and access policies. The result is a simple but powerful pattern. The Data Integrity Suite ensures trusted data delivered through a trusted process. Now that we've connected the data, improved it, monitored it, and operationalized it, we can see the impact. Let's look at the insight this organization is able to uncover. Using this fully enriched dataset, we can now visualize where opportunities exist and turn data integrity into clear, actionable decisions. Let's say our business is evaluating an expansion opportunity at a specific location. We can start by pulling up a location report based on our now trusted address data, including precise latitude and longitude and verified precisely IDs. This report gives us a complete profile of an individual property, its type, characteristics, surrounding context, and the attributes that influence service eligibility, risk, or customer value. That level of insight is only possible because the underlying location data was made precise, consistent, and trustworthy right here in the suite. Beyond a single location, this same well-formed dataset is now ready for downstream use in your BI or spatial analytics tools of choice. We could layer in existing coverage data, analyze geographic patterns, and draw clear insights to support service prioritization and rollout decisions. However you choose to use it, trusted data removes uncertainty. It allows insights to become clear and decisions to be anchored in data that is governed, reliable, and ready for activation. This is the payoff. A dataset that started out raw, inconsistent, and unclear is now a dependable foundation for analytics, spatial intelligence, and AI models that rely on precise, complete, high-quality information that actually reflects the business reality. Across the entire journey, from onboarding and governance to quality assessment and remediation, monitoring, workflows, and insights, the Data Integrity Suite ensures your data is always ready for the decisions you need to make and for the AI systems that depend on it. And that's the power of data integrity. When you trust your data, you can trust the decisions and the AI built on top of it.